You just need to feed it the proper information before answering your question back. So how do you do that? This is going to be the full setup for setting up Llama.cpp with SearXNG. So I've been working on a project, one I would like to show. As of right now, I'll show that we have, if you can see, we do not have Docker installed, but I do have this one file right here that will help me with some of the stuff I want to do. So this application is going to contain two environments, one for SearXNG and then the other one for Llama. Let's just do the setup. So now we've spawned our SearXNG folder with our Llama.cpp. Also have all of our files in here. Our models folder as well was spawned. Now we're going to let it download the Llama LLM. This also fully installs Docker, so this is just for anybody who does not have Docker installed. I'll make a version for people that do have Docker installed, but this was just for myself. We're going to have it so that it is persistent, I guess, for now. That way, if we turn off our computer and turn it back on, it'll still be active. That our connection is done and we have both things running on a Docker, right? So what does that mean? We can run generation tests. So here's our output, as well as some links that we were able to retrieve. So let's say we did want to go to our SearXNG. This is currently what we are running, right? When we're doing stuff like this, this is not an actual website, right? This is just an application that we are running to grab internet data and use the JSON formats. We're going to ask it about the latest technology news. Greece will ban social media for children under 15 from January 2027. Wow, look at that. Did not know about that. Let's just make sure. Oh, yeah, Greece social media ban, but just verifying that the information is correct, right? Let's start up a different application, a very simple application that is just a front end. Meant to do Python 3 test.py. All right, and here is now our front end, right? Very simple front end, just with a box that you can type in. So we'll ask the same question about summarize the latest news in technology. Or summarize the top headlines in technology. Technology include a ban on social media for children under 15. It doesn't say from where, but we can pull it down and you can see these little things. Now we can put these both side by side. We'll do ban on social media news. And right here, you have these, which has like this little drop down as well, right? Our little drop down for our little, which we can also make this into something like that as well. But right now, it's just like this. We need to still filter out some of the information that's coming out. I should have it so that it organizes this if I ever do have it like that. But you have the summary here with some of the links down here. Now we are going to destroy this in one fell swoop. All right. So now you can see Docker PS no longer works, right? And what we're going to do is we're going to just go down my GitHub right quick to show how you can set this up yourself if you want to. First, we just have our preliminary checks just to see what is available, what might not be available, right? So first off, we're going to make our folders, right? So start from the top. Make sure that we're in our home, or we're in our base home folder, right? And we're going to go mkdir Llama.cpp-SearX. Okay. And then we make the second folder inside it, right? And we're just going to cd into Llama, the Llama.cpp folder. We're now going to make our main.py and go over. And now that we're in this folder, we're going to make the environment, right? We just go 3-m env v. Now made our environment using our local Python source b/bin/activate to activate our environment, and then we're going to pip install upgrade pip. Now that we have that sorted out, we are going to make our requirements. And we will post our requirements inside there. Now we can just do pip install -r requirements.txt. Did we not make the directory for model? No. We're gonna just cd into it, cd models, right? We are going to copy and paste this curl. It'll download Llama.cpp. Now we can load it on up so you could see that it works. And that's our first environment. If we wanted to, we can test it. We're just going to go hello. And it gave us back a prompt. So if we reloaded it, it would give us another prompt. And now what we're going to do is we are going to open up a new CMD, and we will back up a little bit. So we'll go cd ... So we're back in our base folder. And now we are going to make our SearXNG. Right? We're just going to git clone that. All right, let me sprucing this up a little bit. We got this all here though. And now what we're going to do is we're going to just go into it. We're going to cd right into the folder. So now we're here, and we're going to, oh, see, good thing that I'm looking at this. So now that we're inside the folder, we're going to go create our Python environment using Python 3.11. And now we're going to activate it. Go Python env/bin/activate. And then we are just doing a pip install -- upgrade pip. Then we are pip install -r requirements.txt and pip install and then we are going to cd, make sure that we're in our base, and we are going to launch it using that. All right, we start getting all these errors, and we're going to need to edit our settings. All right, well, let's just navigate over to it, because we actually need to replace it, not all right, so it'll look like this. It has all these search engines, which we don't need. And yeah, we want to make sure that we are on port 808, binding to 000, right? So this is the most important part. now we can do our little mount again. Okay, it's because we were in the folder, so we couldn't target the actual thing itself. And now again, we are back to where we were originally. So now we can run some of our tests, such as this one right here. You can see that it then triggered the search engine, which it's now processing over here. And we should get our response back, right? So if we did that again, and we will get our response back. We could also paste this up here. And there we get back our prompt as well as our search trigger, right? So we have our search being triggered, being true. We have our prompt up here up at the top. We have our search results, which then help us generate the output. So that's just how these two separate environments work together, right? So that's just for if anybody wants to have those backends set up. The beauty of that is that you can then target this local host every time, and you can just ping it, right? So you can ping it using whatever type of code. It's HTTP request, so you can really just you can essentially just call it from anywhere. So yeah, so now the next thing that we want to do is our Docker. You know, we could have a third environment running in which we run our test app, right? What is it? Test.py? Just test.py. But if we're to trigger this, go latest news, right? See the triggers going. You see how it's processing, and we got a response. So once again, you see our server received the query. Oh, longer summary. There you go. So yeah. Now what we'll do. Okay, cool. So inside our .py, that, save. Now we're just going to create our network. You can see that we create the network of a Llama.cpp. So yeah, I might just delete that just because that's a Docker inspect. All right, so now you can see we have our server up with nothing in it. I guess I will go with the CPU version this time. Okay, so we're just going to make a, probably say make a Docker file. Okay, so now we've created our Docker CPU file, and go create it. And now to create our SearXNG, we're going to just cd into the folder, run the build again. See, we now have two of those, and we can now go that. You can see that we have our two networks there. Now, we should be able to open a new window, test our curl. You see nothing's going on. It needs to be going on there. See, get back search results. We're not organized though at all, so we're just going to toss that. Nice. See, I really do feel like the CPU mode is faster than the GPU, which, yeah, I need to make sure that the environment is set up properly with the GPU mode a little bit more. But yeah, it doesn't matter if we close that. Doesn't matter if we close that because the environment is already running. So now I decided to add the test application setup. We're going to go make directory, test app. We're going to cd into test app. We're going to go Python 3 -m env. Go source env/bin/activate. So pip install Flask, pip install requests, go nano test.py, and I will drop the code on GitHub. I'm going to save that though. And now we're going to make another directory called templates. We're going to cd into it. We're going to make another file called index.html. And I will put that on the GitHub as well, but obviously it's just some styling for buttons and a box to write in. And then we'll go Python 3 test.py. Localhost. Hi. Right. And then we can go, give me the latest news on war in Iran. Right. All right, so there's some of the latest news. Sometimes it'll give back a short response, sometimes a long one. Let's do detailed analysis of the latest news on the war in Iran. Too long, but do long. Longer. Right. So and so now we have our own little application running. I'm going to actually show, though, how I can turn off my computer and turn it back on, and this will still be running. So let's do that. We're going to close this, and we're going to reboot. So I will see you guys in a second. And I will start recording on my phone. I gotta stop my recording. I'm gonna stop my recording. And we are going to power off our device. My computer is now completely off. And I will turn it back on.
And it looks like your
Computer,
PC screen.
shut up. Sorry. Alexa. So we're going to be loading up into our Ubuntu. All right, and we're going to go up to our CMD and paste, just to show that we haven't done anything still. And it's still working, right? The backend architecture is still there, searching the web and interacting with the LLM, right? So now we're back up, and to just talk a little bit more about this, how and why this works the way it does. Okay, so we're just going to go through this very quickly because there isn't much. I mean, there's a little bit to it, but you know, so we're just starting off with our imports, right? We have our basic OS import for logging, so that we can just be provided with logs instead of having to print everything. We have import requests, which is for allowing us to send out HTTP requests. Fast IP allows us to create an application and then mount it onto an IP. And then we have Llama.cpp, and we're importing subprocesses. Subprocesses is for calling CMD lines. Later on in this script, you'll see that we end up calling, I always forget what it is, NVIDIA SMI. Yeah, NVIDIA SMI, which is just for checking to see if we have CUDA installed. NVIDIA SMI, you get your CUDA versions and all of that. But we're just running it at this point for a check. So first off, we're creating a variable of model directory, right? Model directory is going to be our model in which it's just the directory for our model, right? So we have file is pointing at where our main script is located, right? So up at the top, you could see that we're right there. So file, absolute path of where this file is, and then we're getting the directory name, right? So technically, what we're getting is this, right? Because that's where the file is located, and then plus models on the end, right? So it ends up looking like that. And that ends up being our model directory. Makes sense, right? GGUF models, right? And we're just looking through a list, right? So for every F in the list directory of model directory, if it ends with GGUF, right? So we're just selecting the files in the folder that end with GGUF. And GGUF are the LLM's format. So most LLMs will be formatted in either GGUF or a safe tensor file. But in this case, we're creating a list of our GGUFs. And then we're saying if not GGUFs, so if there's nothing there, then we're raising we're raising an error that there was no GGUF found in the model directory, which is our, right, which is there. So nothing in this folder if there's no GGUFs, right? This area right here is our configurations, just to make this clear. I'll maybe split that. So here we're just setting, say, some more variables up, right? So over here we had set up our GGUF models, but here in this case we are setting our models, right? So we're joining the path of our directory and our models to the first index of our models list, right? So any model that's the first one on the list that ends with GGUF is now going to be considered our model path, right? Essentially, we're going model and then name.gguf, whatever, right? Because whatever one's the first one, it's just going to pick that one, whichever one it is. Next, we're setting a variable for our context size. The context size is essentially the maximum amount of tokens that a LLM is allowed to see in order to then generate the response. It's the amount of tokens that it can look at in order to see the response or start forming the response. In this case, we give it a maximum tokens, so a maximum amount of responding with 1,000 tokens. Then we set another variable for our search triggers, which are going to be news, latest, current, update, and headlines. And we set a variable for our seer URL, which is set to our search engine, right? So next we're setting a variable for app, and we are setting it to our fast API. This next line, we're just setting up some basic logging configurations. And then we're setting our LLM to nothing, right? So we're creating a variable for our LLM to sit in, but it's currently going to be equal to nothing. We have a model path, right? But our model path is not equal to our LLM yet, because we're going to want the context size as well to go into our LLM, not just reference the LLM. Next, we're defining if we have CUDA. This is just a function to see if we do have CUDA or if we don't have CUDA installed. We'll create the function of has CUDA, and we're just going try so that we can create an exception, right? And the results are equal to the subprocess.run, right? So it's running the subprocess of Vidya SMI, like I said before. So it's going to just go like this and stand out subprocess pipe, and these are just so that it doesn't actually pop up in our window, and we're just getting back a response, right? So it's never going to trigger that. It's just doing it in the background, and nothing is going to come back. Nothing visual is going to come back. And if that happens, then we are returning that it is true. And if it is not, if nothing comes back, then we are setting it to false. Here's where we first use our fast API, right? So we're going on, so app on event startup, telling our fast API that at the beginning of our application, when we first launch it, what we're going to be doing is we are doing this function, right? So we're loading our model. So we're defining our model, load model. we're looking at the global LLM, which remember is set to nothing. And we're going use CUDA. We're asking for use CUDA, and it's equal to has CUDA, right? So it either does have it or it doesn't have it. And now we're going to set our LLM. So as of right now, it's empty, but here we go LLM is equal to Llama, right? Which is just our object. And we're going model path, right? Model path is equal to our model path, right? That we set up here. And our context size is set to our context size, right? And then use CUDA is equal to use CUDA, right? So it's either going to be true or false. So we're logging a message if that goes through. And then we are logging a second message asking, or we're displaying whether or not the GPU is in use, right? If we have CUDA, if we use CUDA. Else, we're just saying that we're just using CPU, right? Because we're either using CUDA, and if we're not using CUDA, then we're just using CPU. So now we're getting into a little bit more of the meat, right? So we're just going to define our CRX search, right? Creating a new function, and we are accepting one parameter of user search. So again, we're going with a try. That way we can have an exception down at the bottom, just in case if it doesn't go through, we have an error log that happens. And we're going try. First, we're setting our headers, right? So our headers are equal to these applications. This is so that we appear like we are a search engine, right? We're just trying to hide the fact that we're a program and that we're not like a legitimate program. And so we give the headers of that we are a program. Then we're creating another variable for resp, right? All of this is sitting inside, remember, our search, our SearXNG search. So now we have resp, which is equal to, so resp.get is a HTTP request, right? So we're making a HTTP request, and we're going SearXNG, right? So SearXNG, our link, this, right? So SearXNG, our link. So we're creating a parameter of Q, and then we're setting it to user search, and then we're setting the format to JSON. It's telling that when we send a request, we want it back in JSON format. So our headers are set to our headers up top, and then if none of this responds, then we're going to time out for 10 seconds, right? So we have a 10-second timer to time out. If it doesn't happen, resp.raise for status, we're just getting an HTTP response, whether or not this was successful or not, or we're just getting an error code if there is one. Next, we're setting a empty list for results, and we're going for R. So remember, our resp, right, up here is our get. We're getting a request, right? So our resp.json, which is what we were requesting, right? So for every one of those, we are then appending it onto the list of results. We're either going to have a list or we're not going to have a list. So we're either going to be going through the results or we're returning an empty list. But in theory, we should be able to get these back. Let's just give an example where we show how this has thumbnails, right? We have general, category, I saw, image screen, right? There's positioning, all sorts of different little things. But in this case, what we want to do is, so for every one of the responses that we have back, we want to get the title, right? We want to strip the title. The first title that we see, we strip it. The first content or description we see, we strip it, right? The first URL we see, we strip it. And that comes back as a single result, right? And then we're returning results from index 0 up until index 5. So 5 results. And so as you see, we have our response, right? Our 5 2, 3, 4, 5. 5. We're returning it back with our title, our content, our URL. So app.get slash, this is just seeing whether or not we have the model mounted or not, right? So if we wanted to do, right, that's all we're doing, right? We're just getting a message that we're returning the model name, right? So as you can see, EGUF models, right, we had before, but we're selecting the first one on the list, which is the Llama that we downloaded. And so now for our /generate, right? So anytime somebody's going to call the generate function, whenever anybody types /generate, we are going to be calling this next function. So our generate function is going to accept a prompt, right, which is a string. And we are just setting the LLM to global again, right? So whatever the LLM was above, if LLM is equal to none, right? So we're just saying that if it isn't mounted, we're just raising another exception, or we're raising another error, and we're just logging the prompt. And when we're going with another try, because if we can't generate, of course we're gonna wanna say error. So yeah, so we're trying this and we're going search trigger, right? Remember we have our search triggers up here. This is a different variable, right? So search triggers, any word lower in prompt lower for word in search triggers. So essentially what we're doing is we're seeing, first we're going through our prompt and we're saying any words in our prompt, we're making them lower. We're making them lowercase. And we're seeing if any of them are the search triggers. That's essentially what all of this is. But we're looking at our prompt, we're disregarding the fact that they're uppercase, and we're seeing if any of the words are search trigger. And if any of the words are search trigger, we're setting it to search equals triggered in lowercase. Right, just a new variable to see if we have any of them, right? Because if we do have any of them, we need to make sure we know that we have them, right? Because if somebody types news, you could type news a plethora of different ways. You could type news, or news, right? But we're just looking at this word, news, right? But in order to get that, we can just ignore all the uppercases, right? So it always appears as a lowercase. That's the only thing that this sentence does right there, right? And so now search results are equal to our SearXNG prompt if the search trigger is triggered, right? So search results is equal to our SearX search prompt, right? So this is going to be equal to our function up here, right? So essentially what we're doing is we're just returning. So earlier when we returned 5 of them, we're now taking those 5 over here in our generate function, and we're setting it to search results, right? So it's equal to the 5. If the search is triggered, then we'll have these, right? And if not, then it's set to nothing. It's just an empty list, right? So if there is no list, we're not using one. But if there is a list, then we use the search results that we appended up here. Now we're going if search results, then we want to number them, right? So creating a new variable for numbered. So we're just making sure that all of these end up being on a list that looks like this, right? Because we need to go back over all 5 of these, right? We grab all 5 of them, but we don't put them anywhere. So this is us putting them in a list called numbered, that we're creating a numbered structure to then go into our prompt, right? So our full prompt will be answer the questions only using the search results, numbered, right? So it's going to be going like, you're going to have all of these, answer the question only using these, and then it's going to be going, and then whatever the hell I wrote, right? So latest news question mark, answer, right? And so that's what it's getting as our prompt, right? That we're organizing it before it goes into the LLM itself. And so it knows that it's trying to provide us with an answer because that's the end, right? Like the end thing is we're saying answer, like we want an answer back. And then obviously if it doesn't have numbered or prompt or anything like that, we're just setting it to our prompt, right? Which is whatever we typed or whatever question we entered, right? And so then now output is equal to LLM full prompt plus max tokens, right? So our full prompt is either equal to our prompt or our list of searches plus our prompt. So it's either equal to what we typed or the list of search results plus what we typed. Yeah, and then we're just returning our prompt search triggered. And what we're doing here is we're just returning the for you guys. Again, this is formatting. So when we return our generate function, by the end of it, what we're doing is we're returning our prompt, right? We're returning our prompt. We're returning our search trigger if it's true or false, right? If it's triggered. Then we are returning our search results, which are in a list, right? And then we are returning our output, which is the answer to our full prompt if there were searches triggered, right? And then we're just going through choices, right? So we're seeing which tokens there we want to pick, and we're just picking the first token, and we are getting the text and stripping it like before. So we're just taking out all the gunk, right? And obviously if none of that happens, then we're raising an exception. And that's about the gist of this script right here. The cool thing about that is that you can obviously always target this right here, which is what our test application was, right? So the purpose of the test application was just to see if I could create a external app now, right? An app that is not part of this setup in order to interact with the Docker, right? Because then in theory, we could have anything interacting with this network, right? Anything hitting this HTTP. The point was that we wanted to see whether or not we could hit this the HTTP results with everything docked, right? So obviously we did it. We do have everything docked, and we're just hitting HTTP request, right? Yeah, we're not doing anything that we weren't doing in the other one as well, right? We're running our links again down here, search results, right? But we're getting all of that already from our generate function, right? So we're either returning it or not, and then just a basic, some basic HTML, some styling. Yeah, maybe I'll post the application as well. Just because it's the test application, but I feel like the GitHub is already really long, and I need to organize it a little bit better. So just for the setup, but obviously this video will be MacDab up at the top, and I will try to improve the installer that it doesn't erase everybody's Docker and stuff like that. And yeah, I have to double check to make sure everything is correct here. Anyways, hope you guys enjoyed that. Hope you guys found this application interesting. Let's launch our test app one more time. Is that not right? Oh. Okay. Local IP 5000. Yeah. So just to show how that looks again, right? So you can imagine this is a box inside of Unreal or inside of, I don't know, Unity, or let's say you're creating your own device, right? And you power it on and you have it running off of a Linux stuff, right? You could have these servers in the background. I'll give you guys an example. This project right here, but this project was using Comfy UI, right? And it's using LM Studio, right? Like I have to have LM Studio in the background while this is running. I don't want that. I want this, right? I want this. I want my Docker, right? So every single time you launch this, it could either launch those environments, maybe. I'm not really sure how I want to deal with this just yet, but either maybe launch the environments or launch it with the program when I start it up, right? Mount the Docker environments when we start the program. So yeah, that'd be cool. Actually, I haven't touched this program in a while, but the idea would be to remove LM Studio, right? We don't want some third-party program bothering or just on the side there. We want it all packed nicely into one, right? So, anywho, that is my explanation to that, and I hope you guys like that and enjoy that. Much love. And to anyone who finds this useful, yeah, hit me up. Hit me up. I'm always around. I'm always willing to chat and all that type of stuff. So, yeah, peace.